Okay, we'll start our discussion with Cartesian product. Get the clarity, then everything will become easy for you. Cartesian product. Now this belongs to your chapter of sets in grade 11. So let's say you have two sets, okay? Let's say we have two sets and these sets have got, suppose the elements as 1, 2, 3 and 4, 5, 6. These two are disjoint sets, okay? Now let's say I represent this with set A and this is B. The Cartesian product of these two sets is said to be A cross B. And what is A cross B? A cross B itself will also be a set. Try and understand first, then you note down. A cross B will give rise to something called ordered pairs. If you remember ordered pairs, okay. A, B. Achha, the notion that we use is, if the set is represented by A, its babies are represented by small a. If it was X, small x will represent the babies, Y, small y will represent the babies. So it will give you ordered pairs. Now in ordered pair, A, B, let's say this is Neha, this is Zoe, is completely different from Zoe, Neha. A, B and B, A, when we talk about ordered pairs, then, 1 minute, I'm going to, when we talk about ordered pairs, then A, B is not same as B, A. Remember that. Such that, we can write such that means such that A belongs to the set A and B belongs to the set B. Is this understood? This is called the Cartesian product. All ABs. All ABs. So how do I select all ABs? So what I can do is that I can freeze A and pair A with 1, 4, pair A 1, 5, 1, 6. This is the first pairing. Similarly, after this, I can start pairing 2, 4, 2, 5, 2, 6, right? So if we actually try to write now, okay, if we try to write what is A cross B as a set, then I'm pairing with 1, so 1, 4, then 1, 5, then 1, 6. After that, 2, 4, 2, 5, 2, 6, right? Then 3, 4, 3, 5, 3, 6. This is the set A cross B. A cross B are all the ordered pairs which are actually having A mapped from A and B mapped from B. Now, if you try to look at A cross B itself is also a set. So I say if n of A, number of elements of A is denoted by P, and number of elements of B is denoted by Q, this gives us a basic mathematical understanding that for A cross B, I will have the number of elements as PQ. Look here, we had 3 and 3. So number of elements we have here is 3 multiplied by 3, which is equal to 9. Is this much clear? Okay. That's all. That's the basic of Cartesian product. Two sets. And when we are studying all these things, you can have numbers, you can have, names, many other things mentioned. And let's slowly develop the idea and the knowledge of how to arrive at relations from Cartesian functions. So it's like this, see, if you don't know Cartesian product, you will not understand relation. If you don't understand relation, you will not understand function. So let's first get the clarity up till functions and then dive into this chapter. Then the chapter will be getting much more clearer for us. Is this much understood? All right, fine. So let's now go for something called, what do we understand when we talk about relations? Now we'll typically go by language. Our relation, language. Our relation always involves minimum of two identity. Identity 1, identity 2. Can be a father, right? And can be a son. Two identities. And within these two identities, we will be able to map a relation. Blah, blah is the son of so-and-so, or so-and-so is the father of son. Minimum two identities. It can be more than one identity also. These relations will be there. When you, and such relations can be father, mother, country, capital, vowels and consonants, alphabets, whatever it is. When we boil down to mathematics, then these relations will be talking in terms of numbers, So the relations can be something like perpendicular, greater than, equal to, less than, or it can be greater than, equal to, less than, equal to, and blah blah blah. Congruent, similar. These are mathematical relation. So we have to dive into this ultimately. Yes or no? Is this much understood? So we say, okay, get the idea. I had, I have, I'm clear now about Cartesian product. So let me revisit Cartesian product. Now, Cartesian product, no, this keeps on. Cartesian product of two sets A and B is denoted by A cross B. And A cross B will also have some elements, the count of which is equal to PQ. Is this understood? Okay. Relations are subset of A cross B. So when you talk about a relation, let's say I'm trying to plot a relation between A and B, and now we are saying in minimum two identities, change that identities to sets. Relation between two set. Is it one relation, two relation, many relations? We don't know. There can be many relations, but all those relations will be a part of Cartesian product. So all relations will map to the ordered pair. And what is Cartesian product? The Cartesian product has nothing but ordered pairs, A1, B1, A2, B2, A3, B3. So all relations will be subset of the Cartesian product A cross B, right? That means every relation will result, every element of the relation will be an ordered pair of this, but all ordered pairs need not be the relation, right? Now I say they will be related to this, and then let's go again to subset. Okay, let's say I have a set, again basic, I have a set, say set X, and set X has got, say, n elements. So subsets of X will be how much? 2 to the power n. Remember, this is grade 11, 2 to the power n, right? So A cross B has got how many elements? PQ elements. Relations are a subset. So the maximum number of relations that you can map between A and B will be how much? Will be 2 to the power PQ. Is this clear? The number of relations, because relations are themselves a subset, the number of relations will be equal to 2 to the power PQ. Is this much clear or not? This is just basic. Subsets of a, we'll go more deeper. Let's now just try to understand. I created two sets A and set B. I first understood what is Cartesian product. Cartesian product between A and B is the mapping of ordered pairs AB, where A belongs to A, B belongs to B, such that AB is not equal to BA. How many number of ordered pairs can I create? If this A set has got P elements and B set has got Q elements, I can create PQ number of ordered pairs. That is like a universal set. Then comes between A and B, if I take them as entity 1 and entity 2, I can create some relations between them. So relations are a subset of A cross B, the Cartesian product between two sets. Take two sets, and if you try to create a relation between two sets, they are subsets of the Cartesian product between these two sets. And how do we know how many subsets are possible? It's not about elements, huh, children? How many subsets are possible? If a set has got n elements, you can have 2 to the power n elements as a subset. So let's take a set. Let's take a set and say the set has got an element called 1. Then it says 2 to the power 1 means two subsets should come. A set is a subset of itself. So one of the set will be 1, one will be the null set. Are you clear? This is grade 11. One will be the set itself and one will be null set. So number of subsets that you can create. Should I show one example or is it clear? It's clear, right? So let's now dive a little bit more into relations as we are discussing relations. Say, I'm trying to map a relation between a set A and I have a set B. Okay. And I'm trying to map a relation between them. Here you're trying to map a relation. Relation is R. The way you write is a relation, R is a relation from A to B. We can write it like this also. Or we can write like this. R is a relation that maps from A to B. Okay. And then we write such that, and then you can define what is the relation. What does it say about? Right? Okay. Now let's say I'm trying to create these two relations, and let me make it a bit bigger because we'll have some examples which will make it clear for you. Let's say this is A and this is B. Let's say I have got a city whose name is New Delhi. Say I have got Shanghai. Then I have got, say, Colombo. I have got Bangkok. And let's say I have got another city which is, say, Tokyo. The cities. Okay. On this side, I have things like, say, China. Okay. I have got Sri Lanka. I have got India. I have got England. And 2, 3, 4, 5, 1, 2, 3, 4, and say I've got another country called Thailand. Now see, AB. Now, if you want to see the Cartesian product between A and B, you can have ordered pairs. New Delhi, China is an ordered pair. New Delhi, Sri Lanka is an ordered pair. New Delhi, India is an ordered pair. New Delhi, England is an ordered pair. New Delhi, Thailand is an ordered pair. Have you understood? I now say that R is a relation that maps from A to B. And I say R is a relation, and I say that this relation is AB. Understand? Understand. R is a relation from A to B, and the relation is defined by AB. AB is the ordered pair. Doesn't mean only one ordered pair. Can be many ordered pairs. Who will govern this ordered pair? The relation will govern this ordered pair. Where I say B is the, or not B, I say where A is the capital city of country B. Now see, now you're giving a relation. Now every ordered pair will not qualify. Do you agree? Every ordered pair will not qualify because New Delhi cannot be the capital city of two different countries. This is my relation. So I now write R as my relation, and then can we start plotting it? Yes, we have got New Delhi. If we have New Delhi, do we have India? Yes. So New Delhi, India can be an ordered pair. Shanghai. Shanghai is not the capital of China. Beijing is the capital of China. So Shanghai does not qualify itself in this relation. Are you seeing the beauty of it now? However, Colombo is definitely a city. So Colombo maps with Sri Lanka, right? Then I have got Bangkok, BKK, and that maps with Thailand. That's fine. Tokyo, but we don't have Japan out here. Are you getting it? We don't have Japan out here. So Tokyo also does not qualify. Have you understood? Now, when you see this relation, which is mapped from A to B, and we have mapped it with a relation R, and the R relation says that A is the capital city of country B, right? In every of these cases, we will get three things, and these three things should be very clear to you. Domain, range, and codomain. Maybe in grade 12, we will not encounter this. This was all there in grade 11. Domain. What are domain? All possible inputs. Like if you say this is X and this is giving you Y, all possible inputs, right? So in your domain this time, who all will come? New Delhi, Colombo, and Bangkok. Others will not qualify as domain. Understood? Range. Range is the set of all elements, right, of the output set for every mapping of the domain, for every valid input of the domain. So range can take birth only once domain has been fixed. Understand? You gave an input New Delhi, you gave a call an output India. The relation is with India. So what will be your range here? Your range will be India, Sri Lanka, and Thailand. Codomain stands for everything that was a part of set B. So this is all possible values of set A. This is all possible values of B for every valid input from A, and this is all elements of B. बोलो बच्चे ये क्लियर हुआ कि नहीं? ये पहले क्लियर होना है. This example makes it clear. So now you can say, okay, now can you tell me, let's do some recap. How many elements are out here? 1 2 3 4 5. 1 2 3 4 5. 5 into 5 is 25. So how many subsets are possible? 2 to the power 25. 2 to the power 25 types of relation you can actually map. The relation may make sense to you, may not make sense to you, but relations are possible. I gave this example because as a student, country capital relation makes sense to you. I could have also stayed starting with the letter. Okay, so let's see one more example. Are we ready? Okay, let's see one more example, and this example we'll revisit when we actually see again functions. Say and say we have Charlie. Okay. Right. And now I'm naming this as X and naming this as Y. I'm mapping a relation R from set X to set Y in a manner which gives me an ordered pair XY such that Y name starts with X. Y name starts with X. Right, fine. So what all ordered pair we can create? A Amit is one ordered pair. Then A Anya is one ordered pair. Right. So if I see my ordered pair for this relation, we can do this egg drawing also. This is one. These are two ordered pairs. Shall we change our color? Now let's see. B will map to Bill as well as Bobby. Right. And then C will map to Charlie. Is relations understood by you? Okay. Fine. Let's keep this example and let's see functions. I'm covering it very, very fast, but I think this much knowledge will be sufficient for you to sail over. Functions. Functions are important because to understand functions, you understood relations. To understand relation, you understood what is a Cartesian product. So relations are a subset of Cartesian product. Functions will be special relations. Okay, how do we say? A function is typically seen as I used to say in class 10 also, it's a magic pot. This is your function, which is a magic pot. Every function will have something called an input, and every function will give you an output. The input is generally denoted by X. The output is generally denoted by Y, right? Input and output. And these input and output map from two sets. So this set will be known as my set X. This will be known as my set Y. Okay. Every input will give you an output, right? This is another thing to understand. Then we also know that there should be some governing rule for this function. Later on, as we go into classes, our functions will be ILATE is the best way to understand functions. Inverse functions, logarithmic functions, algebraic, trigonometric, exponential. All right. So let's take an algebraic function and let's say this is the function is a 2 to the power x function, right? So 2 to the power x function. Now this is not algebraic, this is an exponential function, 2 to the power x. So if you input 1 out here, it will puke 2 out here. If you input 2, it will give you, right? This is a typical concept about a function. Now, in order to understand functions from relations, we say functions are special relations. Are special relations. Special relation means one sort of constraint I have created, that every function will be a relation, but every relation will not be a function. ये बहुत important चीज है. If you can crack this, half of your understanding will be very clear in the next part of functions. Every relation need not be a function, but every function is a relation. Every relation will be a part of the Cartesian product, the ordered pairs. Every ordered pair need not map to a relation, right? Is this getting clear now? So let's say, what is the special relation? We say it's a special relation. We say a relation R that you map from A to B will be considered as a function f. Just understand, we'll write all this. A relation R mapped from A to B, or say, let's keep it the way we are learning it, from X to Y, will be considered as a function. Will be considered as a function if xy as an ordered pair belong to the function. It should belong to the function, and f of x is equal to y. The function value of this input is equal to y. Let's stop here. This is input, this is output. If you also understand, then this is the independent variable. Y equal to 3x plus 2. You can enter anything that you want for x. This is the dependent variable. This is the independent variable, this is the dependent variable. So a relation between x to y will be considered a function if xy as an ordered pair belongs to the function. We'll get it clear. And we say f of x should be equal to y, means the function value of that input x should be equal to y. For in this example, f of 1 will map to f of 1. Say 1 is an input out here. Then you should have a 2 out here, such that f of 1 is equal to 2. This mapping, based on this function, this is my mapping. Is this clear? F of 1 is equal to y, where x will be always known as the pre-image, or you can also call it as the domain, and y will be known as the image, and I will call it as the range of the function. Right? Now the difference between this, the main difference between function and this was what better? This was a relation that we had mapped. Now we'll map a function. We'll see what is the difference. In a function, every single input should have a unique output. Are you understanding? Every input should have a unique output. For every x, we say a relation from x to y is a function if xy belongs to the function and f of x equal to y, and we use the word for every x belonging to x and every y belonging to y. The unique thing is, for every input you should get a unique output, right? Means for one input you cannot get two output. In functions, now this is the crude part of mathematics, in functions this drawing is possible. Is it possible? No, it is not possible. In functions, okay. However, this is possible. Every input has to have a unique output. One input cannot have two outputs. Maybe you are getting a little bit clumsy, and that's why I gave these examples. Let's see, it will become clear from one example, and you yourself will be able to explain everyone. Let's see one function. Our function is f of x is equal to sine x, and we have the x inputs here and the y inputs out here. Sine x is a sine function. We say it's a function. Let's see. Sine 0 is 0. Similarly, again, sine 180 is also 0. Sine 180, sine 0 is 0. Sine 180 is also 0. This can have two pre-images. This fellow cannot have two images. No two, you cannot have. Tell me an angle which gives you two sine values. Just think. Tell me an angle which gives you two sine values. No, not possible. Sine 30, do you have two values for it? But there are two angles which might yield the same sine value. Sine 0, 0. Sine 180 is also 0. Yes or no? Sine 360 is also 0. Every input has to have a unique output. Iska do nahi ho sakta hai. Okay. This gets very interesting from here. Let's see one more example. These are taught in, topics in books abroad. How to understand graphically that suppose a plot is given to you. This is a plot. Is this a function or not? Right? Is this a function or not? Simple. If this is a function or not, we will just do the vertical line test. What is the vertical line test? Draw one vertical line. Let's say this is a function fx. And I want to test whether fx is a function or not. That means this is x and this is y. This is some x equal to c, right? And for that x equal to c, you are getting a value f of c. For this particular value, are there two points? No. But let me say, if I'm going fast, just let me know. If say, I have a plot like this. This is a plot. The plot has come like this. And you do your vertical line test. Let's do our vertical line test. There is some x equal to d for which you have blah blah value, blah blah value, blah blah value. Sine 30 cannot give me three values. This is not a function. Makes me ask you a question then. So many days we used to see a function written f of x is equal to root x. Now, is this a function? This is what is not debated in schools. Is this a function? Let's take, let x equal to 25. Then what is f of x as per your problem? Root of 25, which should be plus 5, minus 5. Function nahi. This is not a function. But sir, in many chapters we have seen like this, they print like this. They forget to print one small statement out here. Only the positive values you will take. Here, not x is greater than equal to 0. We will say for all outputs that are greater than equal to 0. Y, so we will say y, f of x means y, right? Y is equal to root of x will be a function if y is greater than equal to 0. Because the negatives are not considered. Otherwise, this is not a function. Imagine root function. So root functions come in which manner? The root function, typically square root function, they will show, map it like this. 25, 5, but this is 5. Minus 5 will also give you this figure. We are not taking the negative side of it. Itna clear hua? So let's go back here. Let's go back to this one. This is a relation. This is not a function. Because A mapping to Amit, A mapping to Anya will not be a function. It's a relation. Function cannot have two outputs for one input. Remember that in your head. And in next chapter, we will study what? 1-1 function. 1-1 function means for every one input, one output. One input, one output. And onto functions we will be studying, right? When we go to functions. Is this much clear about function? Functions can be tested. See, another way to test function is, as I saw on your linear diagram, let's say you have a function. Suppose this is a function. This is how we test onto functions and all. You can do a horizontal test also. So horizontal test gives you what? There is some value x for which I get a fx, x1, fx1, and there is one more value x2 for which I get a value fx2. This is valid. This is function. Sine 30 and sine, if you go to 120, it will not take up sine 30. So you take it like say sine 360 plus another 30, sine 390. Both will give you same values. But there are two different inputs giving me the same value. That is possible. Means in our diagram of eggs, this is possible. This is possible. Opening out like a fang is not possible in case of what we call functions. So let's put a summary out here. A summary. We first understood what is Cartesian product. Okay, we understood what is Cartesian product, and that was A cross B. So this is like your universal set. Then we understood what is a relation. So relations are subset of A cross B always. Relations are subset of A cross B, right? Then you give a fair idea about a function. A function will always be a special relation. Such special that for every input x, you should have unique output y, right? So the base difference between relation and function is, in relation this is possible, in function this is possible, the other one is not possible. In function you cannot have, this is not possible. A sine 30, just remember sine 30 or a sine 0. A sine 0 cannot give me two values, but a sine 0 and a sine 180 can give me the same value. Clear? This is relation. Let's see if I've missed out anything from. Fine. We are now ready to get into grade 12 part. So let's get into grade 12 part. In grade 12, we will be studying relations, and we'll study three different type of, rather, of course, four different type of relations, or three major, four we will say relations, which will be actually working on a particular set A itself. So you will have a set A, this is a set A, and you will again take a set A, and you are actually trying to find a relation between set A to A. A to A also we can create a relation. This is what is there in your grade 12. Okay, so let's say I have a set A which has 1, 2, 3. I have 1, 2, 3 as the elements. Obviously, if 1, 2, 3 are the elements in set A, in the other set also my element should be 1, 2, 3, right? And I right now I'm mapping a relation from A to A such that it creates XY ordered pairs. Now the beauty part is XY ordered pairs. Obviously XY, why we are saying, because we may get a different output also. For a 1 we may get a different output, that's why we write XY, but they are coming from the same particular set. Please understand that. Or you could have written A, what do you call, AB also. Please understand. Previous classes we used to see two different sets. Now you are saying the same set. Sets are same, but the relations are going to pop out two different, what do you call, elements in the ordered pair. It is not necessary that 1 will always map with 1, or 2 will always map with 2, or 3 will always map with 3. Say suppose there is the relation in which you have mapped 1 with 1, 2 with 2, and 3 with 3. Is this a relation? Yes, it's a relation. This relation is very unique. This is very unique. And this will appear only once. That's why this relation is known as a identity relation. This is called an identity relation. This is very unique. Identity means an identity relation. So we say a relation is said to be an identity relation between A to A, it is XY, for every X belonging to X and every Y belonging to where Y also belongs to this and XX. So it will be a XX. It won't give you a different. And this is an identity relation, just we need to know it for the namesake. So here we say identity relation where X belongs to A, Y belongs to A. For every X belonging to A and y belonging to A. Is this much clear? Just remember this. An identity relation is usually, you'll always get doublets. That's it. So let's see another relation. Not identity. Let's see one more relation. R is a relation that is mapped from A to B such that it gives you an ordered pair xy, and the criteria that we are taking here is the x such that x plus y is less than equal to 6. X plus y is less than equal to 6, right? Where x belongs to A and y also belongs to A. Let's prepare this. Let's see. Let's try to map this. Get me those ordered pairs whom if I add, I get a sum which is less than equal to 6. True. Let's start with 1. I pick a 1, 1 as an ordered pair. See, you have to have an x. Where does the x come from? A. You have to pick a y. Where does the y come from? A itself. Between them form ordered pairs such that addition of them should be less than equal to 6. Does this qualify? Yes. Does 1, 2 qualify, beta? 1 and 2? Yes. Does 1 and 3 qualify? Yes. Does 2 and 1 qualify? Does 2 and 2 qualify? 2 and 3 qualify. Then 3 and 1 qualifies. 3, 2 qualifies. 3, 3 qualifies. Don't you think that your relation R is exactly same as A cross A now? The Cartesian product A cross A. This is called a universal relation. What do we call it? Universal relation. So what is a universal relation? Identity relation will give you only doublets where every input is mapped with its own image. Okay, this is called a universal relation, and the universal relation is equal to the Cartesian product A cross A. Dekho, please understand, you have learned two things. Just check with yourself whether you are fine with these two or not. Identity and universal. Identity beta is going to occur only once. Cannot have identity coming once again in some different form. एक ही बार होगा. 1, 1. Every xy where x belongs to A, y also belongs to A. For every x belonging to A, the y is also the same x. Universal is when you create a relation that you got so many ordered pairs which are exactly same as the ordered pairs of the Cartesian product. Now look here. What our friend Sarthak might also do, he might start with, he says, why are you, sir, starting with 1? I would like to start with 3. So he starts writing 3, 1, 3, 2, 3, 3. And then he says, now I'll go to 1, 1, 2, 3, 3. No issues. In a set, order of the elements never matter as long as the elements have been selected. Set of all vowels of the English alphabets. What are they? A, E, I, O, U. Need not be. U, E, O, I, A is also vowels. Order of the elements does not matter as long as all the elements have been selected. Okay. Now create one more relation here. R is a relation from A to B such that, okay, create a relation such that it creates ordered pair xy such that x plus y is greater than 6 for an x belonging to A and a y also belonging to A. Let's map this relation. Create those ordered pairs. So let's say this is R1 and let's say this is R2. Now create those ordered pairs such that their sum exceeds 6. Do you have any ordered pair? No. This is known as a, or we call it phi. This is null set or phi. So this and this together are known as trivial relation. Null set and universal relation, and these are known as trivial relations or empty relation. This we don't call it null set. Sorry, I wrote null set. We call it an empty relation. Okay. And these are trivial relation or trivial solutions. Yahan bhi chapter has not started. Is this much fine? Identity. Missed out anything for you? No. Just check. We'll cover this much also today. It will be fine. So let's recap once more. Now in grade 12 we have entered and we are talking about relation, and we will be seeing relations within a set A itself, in which we first understood what is a identity relation, right? Then we understood what is a universal relation. A universal relation R is such that it is same as A cross A. Always remember that. And then we understood what is a empty relation. And the empty relation R is equal to null set of phi. Okay? R is equal to phi. Children, tell me, so far is it clear? R is equal to phi. These two are also known as trivial solution or trivial relation. That's it. And now comes our syllabus, where we need to study three types of relation. The first one being known as reflexive. The second one will be known as symmetric. The third one will be transitive. There are borderline differences. Symmetric is the cutest one. Everyone understands symmetric. People jumble all in transitive as well as in reflexive. And then we'll see some examples. We will see whether they are reflexive or transitive or whatever it is. Okay. By definition, it will never be clear. We say a relation R mapped from a set A to A, okay, is reflexive, is reflexive if you get an ordered pair AA. You get an ordered pair AA for every A belonging to A. For all A belonging to A. Nobody understands by this definition. It will never become clear. Then you will first ask me, sir, you are getting AA for every A belonging to A. You mean to say then what is the difference between this particular relation and the identity relation? So let's take one example. Okay. So let's say our set is A equal to 1, 2, 3. Relation R will be called reflexive. Please understand. Relation R will be called reflexive. For that, there has to be two criteria. There has to be a mandatory mapping and there has to be one optional mapping. Here is what children get into confusion and they are unable to identify the relation. Mandatory. The mandatory is that for every A to A means identity has to be inside. This mandatory part is nothing but the identity relation. Right? So what is our set? 1, 2, 3. Agreed? You can also think it like this. This is also A, this is also A. 1, 2, 3, 1, 2, 3. So the identity part should be there. 1, 1, 2, 2, 3, 3. Right? Then we are saying it as A, and another A for every A belonging to A. Your wish. I have not included all. I have not included all. But all could have been here also. Are you understanding? If this part is not there also, still it is reflexive. So point now comes. Is the identity relation reflexive? Yes. Are all reflexive relations identity? No. Okay, next question. Is the universal relation reflexive? Yes. The universal relation will contain these three. देखो भाई, reflexive होने के लिए you just check whether the identity word has come or not. let's take one more relation. Okay, let's see. R2 is 1 1 3 3. Is this reflexive? No. Why no? No mandatory doublets. Where are the doublets? For every A belonging to A should be there. Is this reflexive? No. Is this identity? No. आपको समझ में आ रहा है अभी? So reflexive में लिख लीजिए. You write with this example. That is the best. Every element should be related to self and can be related to others as well. This is mandatory. This line please don't miss. Sarthak, you understood, right? Yeah. Every element should be related to self. The whole chapter hovers around these three understanding and can be related to others. Children, whatever I started my discussion with for this chapter, they are not for this your grade 12. That was pull out of grade 11. What you should understand in grade 12 is Cartesian product से universal relation मिलता है, right? And that is a universal relation is equal to, but Cartesian product when we say we mean A, B. देखो grade 11 कैसा था? Grade 11 had a set A, had a set B. So you married them and you called them as Cartesian product. Grade 12 is having only a set A and you are marrying it again with A. That's also a Cartesian product. But now the entire elements will be known as A cross A will be known as a universal relation. A cross B is not a universal relation because in A cross B we said universal relation has to be a subset of A cross B. Are you getting this thin line difference what I'm trying to say? Have a look once again what I'm trying to say. In grade 11 we had a A and we had a B. Once you do A cross B, you get what is known as the Cartesian product. Relations are subset of this. Found it? In grade 12, you have a A, you have another A. When you create a cross A, yes, this is a Cartesian, but this is something special that it is also the universal relation. There's a difference between these two. Here, everything will not be a relation. Here, everything is a relation. Because you're mapping to yourself. Mapping yourself. Ye clear hua? Okay. So, is reflexive clear? So, reflexive, please write down. Reflexive, did you write down this line that every element should be related to self and can be related to others as well? You may relate, you may not relate. So, I would say it should be doublets plus other ordered pairs. Right there. Doublets plus other ordered pairs. All 1 mark question qualifying things. Doublets plus other ordered pairs. All identities are reflexive, but all reflexives are not identity. Clear, Zui? Because to be identity, only the first part should be there. Clear? Okay. So now I again take an example. A as a set which is equal to 1, 2, 3 has these three elements. I am trying to map a relation R from the set A to A. I could have also written this as a relation A to A, okay, such that you are able to see if AB as an ordered pair, okay, we say AB, if AB belongs to R. Now this, if AB belongs to R, implies BA should also belong to R for every A belonging to A and B also belonging to A. This is very simple. Okay, what does this sort of a relationship is known as symmetric relationship. Symmetric. Okay. In symmetric, you will not be asked to create the relation. You will be given a relation. You have to identify whether the relation is symmetric or not. So look, we say R is a symmetric relation. If R is a symmetric relation, this relation should open up ordered pairs where you should be able to find a AB as well as a BA. Agar AB mila, if Jadid Das is there, Das Jadid should be present there. So let's very example. Let's say I create a relation R now, which has 1, 2, 2, 1. Is this a symmetric relationship? Yes. Yes. Need not be everything. See, look at what was in identity. Every element should be mapped to itself. What was reflexive? Every to itself mandatory, and every to others maybe, may not be. What is here? If I am with you, you are also with me. For every I present in the set. For every I present in the set. What are the every I's present in the set? 1, 2, 3. And for every U's present in the set. 1, 2, 3. So let's say if I create it like this. Okay. Sorry. So let's say I have a relation R2 and it is this. What relation is this? Identity. What relation is this? Reflexive. Reflexive needs only. What relation is this? Symmetric also. For every 1, 1, 1, 1 is present. For every 2, 2, 2, 2 is present. For every 3, 3, 3, 3 is present. We don't repeat the orders. Acha, Neha confused ho rahi hai. Neha dekh. AB in Cartesian or ordered pair is different as BA. AB is different from BA. Will I again write AA? In sets we don't do this. Elements of a set are never repeated. Grade 11. 1 1 के लिए और एक बार 1 1 नहीं लिख सकते भाई. These are the small catches in this chapter. AB, BA are two different ordered pairs. All right. AA, how do you know this was more? This was slim A, stout A, slim A. We don't write like that, right? Remember, AA is AA. I will not write it twice. So, which brings me into consideration that is an identity relation symmetric? Yes. Is it reflexive? Yes. So let's see some more examples for reflexive. Okay. Let's say I have got a relation R which says 1, 2, 1, 3, 3, 1. Is this symmetric? For a 1, 2, I don't have a 2, 1. No point in checking further. If one ordered pair fails, it fails. You'll not check this. Are we fine? Let's do now. I brought this. Let's do one by one. Okay? Let's do one by one. Chalo. 1, 1, 2, 2, 3, 3. What will you call this relation? Identity relation. I will also call this relation reflexive. Okay, why are you calling it identity reflection? An identity reflection is because this is mapped from A to A, RB relation in set A. Here you won't say A to B. It is in 12 it's all set A. So every element has its doublets should be there. And are all doublets there? Yes, all doublets are there. So this is reflexive. Okay, identity. Then reflexive says mandatory all doublets plus other relations are possible. So optional criteria are not met, but mandatory criteria is met. So yes. How about 1, 1 and 2, 2? Which one? Yes, this is symmetric also. Very good. This is symmetric also. Okay, 1, 1 and 2, 2. Yes, this is symmetric. Why is it symmetric? For every 1, 1, I have a 1, 1. For every 2, 2, I have a 2, 2. But sir, they are not repeating twice. Oh, idiot. We don't repeat the elements of a set. As simple as that. Next. 1, 2, 2, 1, 1, 3. So can I call it as a reflexive? No. Can I call it as a symmetric? No. How about this? For a 1, 2, see a 2, 1 exists. For a 1, 1, 1, 1 itself qualifies. For a 3, 3, 3, 3 itself qualifies. For a 2, 2, 2, 2 itself qualifies. So it is symmetric, no doubt. Is it reflexive? Yes, it is reflexive because this is a particular one which qualifies the mandatory criteria as well as optional also, and this is symmetric also. How about this? For a 1-1 qualifies, 2-2 3-3. So for up till this much we can say it is reflexive. No question arises. Symmetric, it fails because for this one we don't have. So I'll call this as reflexive. For symmetric, this fails. How about null set? Null set, empty relation is neither reflexive nor this nothing. This is nothing. A cross A. I told you, A cross A is a universal relation. Universal relation will have the identity also. It will have the reflexive also. It will have the symmetric also. We have not studied transitive, but it will have the transitive also. Abhi clear hua thoda yahan tak. So as we finish till here, just ask yourself, is uske baad we'll take 2-3 classes in universal, empty. Okay, these two form a part of your trivial. Then we learnt about identity as a part of mandatory to be reflexive, and then we found out what? Symmetric. Right. Our next is transitive. I'll just give an intro and we will discuss it again in next class. Transitive. So we have a relation R from A to A, and R is said to be transitive. Okay, transitive. If you have a AB belongs to R. If AB belongs to R and BC also belongs to R, AB belongs to R, zeroth law of thermodynamics. So and so is in thermal equilibrium with this. It should imply that AC also belongs to R. This criteria has to be met in order for a relation to be transitive. If AB belongs to R and BC belongs to R, so it's a transitive. Dekho beta, you know, AB, B, and C, so AC belongs to R. But there is a big catch in this one. That catch you will realize if I give you some examples. Okay, now the easiest one is, again, my set is A, which is having 1, 2, and 3 as their elements. I say a relation R, okay, in which I have got a 1, 2, I have got 2, 3, and I have got 1, 3, which is very easy. AB, BC, AC. Is it transitive? Yes, it is transitive. Yes, it is transitive. I have a relation R in which I have a 1, 2. I have a, say, 2, 3. Is it transitive? If AB belongs to R, I'm saying it belongs to my relation. BC also belongs to R. There should be a AC which should belong, which is missing. Okay. I have a relation now. What about this? Is it transitive? No. This is where they all go for wrong. Criteria for this definition. If AB belongs to R and BC, is there a BC? No. So we'll not check for this at all. Implies that this should. This is transitive. Transitive क्या बोलता है? AB है ना? AB है तो तुम transitive हो. It's very easy to understand in Hindi. In AB है, you're transitive. लेकिन if AB के साथ BC है, then AC होना ही पड़ेगा. It's transitive. If this belongs to R and means this may happen, may not happen, may or may not. If it is may, then this is mandatory. If it is may not, you're just having this. It is transitive. समझ में आया? बड़ा interesting है. Now look at the identity relation once again. 1, 1. You have a 1, 1. Do you have a 1, 2 in the identity relation? No. Do you have a 1, 3? No. I only have a 1, 1. Very good. Acha, see, this was only 1. I say I have a relation which is 1, 1, 2, 2, and 3, 3. Acha, look at me. This is a AB. For this AB, do you see a BC? No. So up till here, transitive cleared. This is a AB. A, B. For this, do you have a BC? To have a BC, you should have 2 something, na? Because your B is 2. This is A, this is B in the first criteria. I should have another some ordered pair beginning with 1. I don't have. So no BC. Up till here, it is transitive cleared. Transitive cleared? Transitive cleared? Yes. Here AB is 3, 3. If you want to have a BC, you should have 3 something. 3, 1, 3, 2, whatever it is. अरे देख नेहा, हमेशा आगे ही जाना पड़ेगा, ऐसा नहीं है, आगे पीछे भी कर सकते हैं हम लोग, आगे पीछे भी कर सकते हैं. ये ए है, ये बी है. अगर ए बी है देन चेक करो क्या बीसी है. बीसी होने के लिए 3 समथिंग शुड बी देयर. इज देयर एनीवन हुज प्री इमेज इज 3? नो, ये आया ही नहीं. बस इसी पे आंसर कर दो. Have we understood this? Transitive. There are some more examples, like say
So an identity relation is
say 1 2 one more was there, yeah, 1 2 1 1 and suppose you have 2 3. इसको खत्म करेंगे और आज छोड़ेंगे आपको. This is a relation. Now is this relation transitive or not? We will see. 1 1 1 2 1 1 2 3. Okay, 1 1 1 2 2 3. We will see whether this relationship is transitive or not. How to check these things? 1 2 A B B C, some things are there. So या तो ये A B. So either you can take, or देखो 1 2 1. So we can do it this way. If I take 1 1 as my AB, then my next thing should be what? 1 2. And if this is appearing, then I should have another AB BC AC. I should have another 1 2, which I am having. ये ट्रांजिटिव तो है इससे देखा जाए तो. अच्छा, उससे देखते हैं. Which one? 1 1 2 3. No, it should be AB 1 2 and 2 3. Okay, say if I start with 1 2, this is AB. Okay, AB, then it should be BC. B again has to be 2. With 2, do you have something? I have 2 3. AB BC. I should have a 1 3 with me. Do I have a 1 3 with me? No, this is not transitive. ऐसे ही आप डिसीजन नहीं ले सकते. ये थोड़ा सोचने का चैप्टर है. Did you understand the? Sarthak, you were asking something. In a universal relation, you were saying identity relation.
I was just saying that any identity relation will always be reflexive.
हाँ, सोचने का नहीं, आप खुद सोच के देखो. आइडेंटिटी रिफ्लेक्सिव होने के लिए आइडेंटिटी मैंडेटरी है. सिमेट्रिक होने के लिए 1 1 का 1 1 होना चाहिए. आपको क्या पता, पतला 1 मोटा 1, 1 1 का 1 1 है, 2 2 का 2 2 है. एंड इन ट्रांजिटिव वी विल से फॉर एवरी 1 1 देयर शुड बी 1 1 2. वो 1 2 तो है ही नहीं, तो आगे चेक ही नहीं करेंगे. ट्रांजिटिव यू राइट इन योर ओन वर्ड्स इन सच अ वे, इट्स सिंपल. इफ यू सी ए बी एंड then after this there can be 2 things. There can be a BC and there can be nothing. If there is nothing, ये transitive है. अगर BC है तो थर्ड चेक आपको करना है कि क्या AC आता है कि नहीं, तभी transitive है. Zoe, did you understand? If you get a AB, check whether you have a BC. If you get a BC, then see whether you have a AC. Then you are transitive. If you get a AB and you see nothing, then it's transitive. And I can put it up later, like, you know, as a picture. I'll give it to you on your WhatsApp. I think, like, yeah, this was one example. 1 2 2 1 2 2. How about this relation 1 2? Tell me 1 2. Is 1 2 transitive? Yes. I have 1, 2. I should have another set, should be 1 something. It's not there. So I don't check further. This is transitive. How about this one? This one you know how to check. When you get the same things, create 2 scenarios. You understood how to create the scenarios? I am starting with 1, 2, A, B. There should be B, C. Means something starting with 2, which is 2, 1. If that be the case, AC should be there, 1, 1 should be there, and this is present, this is present, this is present, transitive. But let us try out another option. Okay, let's say if I try 2, 1, and then I should try get 1 with something. 1 with what? Say 1, 1. Then 2, 1 is present. 2, 1 is present, transitive. It could have also been 1, 1 ki jagah pe 1, 2. In this case, is 2, 2 present? No, this is not transitive. Check all options.
It's not
It's not transitive. Right?